You suppose it was recording before that? Okay, so I see the look in your eye, and you guys are looking at me, and you're like, can we please have one more formula? How about a long, confusing formula? Yes. There we go, right? Okay, so sometimes it is that you know the radius of the corner, and I think we calculate like a 114 meter radius, which is giant, right? But freeway, like the radiuses on freeways and stuff like that, they are really, really big. They're like hundreds of meters, okay? Just to keep the G-force down. But oftentimes, like with a car, we know the velocity we're going. Maybe we know the radius of the corner or something like that, and that's the easiest thing. Sometimes it is that we don't know how fast we're going, but we know how long it takes for something to go around the object. Like, for example, how fast is the Earth going in its course around? We know we're 93 million miles or something from the sun, yes? Is that what it is?
It's a long distance.
Oh, wait, no.
93 miles.
It's only 93 miles, that's what it is. It's like from here to the coast, right? Or wait, maybe the speed of light is 93 million miles per second. Is that what it is? How far are we from the sun? Here.
You're the teacher, come on. Hey, wait, it changes.
No. This is bad. This is like on YouTube. We got to get it right. Yeah, bathroom for you. Go for it. Okay, here we go. Earth. Earth-Sun distance 149.6 times 10 to the 6th kilometers. Yeah? Okay, that's kilometers. Divide that by 1609. Right? Multiply by, 1,000. Hey, I was right. Is it 93 million? I think so. That's good. So what is the speed of light in miles per second?
100 miles per second. It's 186,000 miles.
186,000 miles per second. That's the one I'm confusing. Okay, this is good.
Found it's
now,
the fastest thing in the universe, though.
I figured that out. Okay, we're back. So we know how far we are from the sun. Do we know how fast we're going? No, not necessarily, right? Not necessarily, but on the tip of your tongue, I'll bet you know what time it takes to go around the sun.
It takes 365 days.
365 days to go around. Yes. Okay. The excitement is over. Let's be quiet now. Okay, so what it is that we know then for the Earth going around the sun is that we know its period. And the symbol for period is a T. Okay, now we know it in days, 365 and some change days, almost a quarter of a day, but not quite. So if you keep adding a day every like 4th year to compensate for that, you're actually off. So every 100 years you don't add a day or something like that, right? But anyway, that's what it is in days. The periods we're going to use, we should always use in seconds, because if they're not seconds, then we won't have like meters per second squared. We'll have meters per year squared or something, or day, right? Okay, so the period of the Earth's rotation on its own axis is what? 23 hours, 56 minutes, 4 seconds, right? We all know that. Everybody knows that, right? Okay, the period of the red hand on the clock is 60 seconds. And for the long hand, it's 60 minutes or 3,600 seconds. And for this guy, the short one, 12 hours. Or if it's a 24-hour clock, some kid always goes, well, what about a 24-hour clock? Well, that clock is 12 hours, right? Okay, so that's what the period is. Now, the second thing is that this tangential velocity, okay, the tangential velocity is just circumference divided by period. Does this make sense? Not in your data packet. It's a very handy formula, not in your data packet. Memorize it. Very handy in this chapter. Does it make sense that if you divide the distance you travel by the time it takes to travel, that you've got the velocity? Yeah. Yeah, except that this has the units of meters and seconds, so, but yeah, hold on to that thought.
What?
Okay, so now, what I'm going to do, and it's not going to be pretty, is I'm going to substitute this velocity in for that one, and we're going to get a formula for acceleration with radius and period instead of velocity. Right? So this we could use this to calculate the centripetal acceleration of the Earth around the sun and all these things, right? So let's plug that in, v squared over r, right? So we go 2 pi r over t squared over r. Yes? And the squared squares everything. It leaves nothing unsquared. 4 pi squared r squared over t squared over r. And now we are going to cancel. We are going to cancel. We are going to cancel r. Here we go. So our final formula is that the acceleration is 4 pi squared r not squared over t squared. Okay, these are our formulae for centripetal acceleration. So depending on what you have, if you have the time it takes to go around once, use that one. And if you got the tangential velocity, use that one. And this one's always handy to have, just kind of in the background, but you got to remember that, okay? This is like the I hated this formula as a student because I could never remember it, and I had to remember all mine, right? Aren't you used to like pi r squared? Like pi not squared and then r is squared? This is like the opposites. So there it is. Let's try this one, shall we? Try that one. Put that in your smipe and poke it.